Hello, I'm Dr. Darnell, and welcome to this video about decision theory. At the end of this session, you will be able to summarize the decision theory approach, discuss the steps of problem-solving and decision-making, describe analysis and decision-making, understand decision modeling, identify decision-making science techniques, summarize an example of decision modeling. Herbert Simon, an early pioneer of decision theory, was also among the pioneers of several other modern-day scientific domains, such as artificial intelligence, information processing, problem-solving, organization theory, and complex systems. He won the Nobel Prize in 1976 and the Turing Award in 1975 for his theory of corporate decisions. In 1947, he published his theory of corporate decision in the book Administrative Behavior, A Study of Decision-Making Process in Administrative Organization. The first edition was published in 1947, and the fourth edition was published in 1997. In it, he asserts that decision-making is the heart of administration, and that the vocabulary of administrative theory must be derived from the logic and psychology of human choice, and it attempts to describe administrative organizations in a way that will provide the basis for scientific analysis. Simon described an organization as a complex network of decisional processes, all pointed towards their influence on the behavior of its members. He viewed the organization as containing distribution and allocation of decision-making functions. According to him, psychology of the organization is to be found in the process where the organization influences the decisions of its members, supplying these decisions with their devices. Thus, the best way to analyze an organization is to find out where and by whom the decisions are made. Decision-making theory approach. Decision-making is the core of management, and management is synonymous with decision-making. A variety of names exist for the body of knowledge involving decision theory approach. It's known as management science, operations research, and decision science. Decision theory approach is based on the scientific method and takes extensive use of quantitative analysis. Decision theory extends Frederick Taylor's scientific management theory. The scientific management revolution of the early 1900s, initiated by Taylor, provided the foundation for the use of quantitative methods in management. Modern decision theory is generally considered to have originated during World War II period, when teams were formed to deal with strategic and tactical problems faced by the military. These teams, which often consisted of people with diverse specialties, for example, mathematicians, engineers, and behavioral scientists, were joined together to solve a common problem by utilizing the scientific method. After the war, many of these team members continued their research in the field of management science. Two developments that occurred during the post-World War II period led to the growth and use of management science in non-military applications. Linear programming and modeling. First continued research resulted in numerous methodological developments. Probably the most significant development was the discovery by George Dancing in 1947 of the simplex method for solving linear programming problems. At the same time these methodological developments were taking place, digital computers prompted a virtual explosion in computing power, and computers enabled practitioners to use methodological advances to solve a large variety of problems. Today, the decision approach to solving a problem begins when a mixed team of specialists from relevant disciplines is called to analyze the problems and propose a course of action to management. The team constructs a mathematical model to simulate the problem. The model shows in symbolic terms all relevant factors that bear on the problem and how they are interrelated. Eventually, the management science team presents management with a rational basis for making a decision. Decision-making theory approach. Decision theory defines 7 steps of problem solving. The first 5 steps are the process of decision-making. Problem solving can be defined as the process of identifying a difference between the actual and the desired state of affairs, and then taking action to resolve this difference. Decision-making is a term generally associated with the first 5 steps of the problem-solving process. Thus, the first step of decision-making is to identify and define the problem. Decision-making ends with the choosing of an alternative, which is the act of making the decision. For problems important enough to justify the time and effort of careful analysis, the problem-solving and decision-making process involves the following 7 steps. Step 1. Define the problem. You realize that you need to make a decision. As a manager, you must become aware that there is a problem and that it is sufficiently important for managerial action. Clarify and define the nature of the decision you must make and address the root cause and not symptoms of the problem. This is a very important step. Step 2. Determine the set of alternatives. The next step for making a good decision is to collect appropriate information on the issue and identify alternate solutions. As you collect information, you will probably identify several possible paths of action or alternative. In this step, you will first list all possible desired alternatives. There should be a need, a valuable judgment, that which the information is relevant to the decision making. Number 3, determine the criteria for evaluating alternatives. Determine evaluation criteria you will use to decide which of the different alternatives is expected to meet the objectives. Number 4, evaluate the alternatives. With the evidence in this step, the decision maker evaluates various factors such as feasibility, desirability, accessibility, and adaptability of the decision. 5, choose an alternative or make a decision. Once you've weighed all the evidence, you're ready to select an alternative that seems to be best one for you. 6, implement the selected alternative. You're now ready to take some positive action by beginning to implement the alternative you chose in step 5. Step 7, evaluate the results. In this final step, consider the results of your decision and evaluate whether or not it has resolved the need you identified in step 1. If the decision has not met the need you identified, you may want to repeat certain steps of the process and make a new decision. For example, you might want to gather more detailed information or somewhat different information to explore additional alternatives. Quantitative and qualitative analysis. This image shows the analysis phase of the decision-making process. May take two basic forms, qualitative and quantitative. Qualitative analysis is based primarily on the manager's judgment and experience. It includes the manager's intuitive feel for the problem and is more than art than a science. If the manager has had experience with similar problems, or if the problem is relatively simple, heavy emphasis may be placed upon a qualitative analysis. However, if the manager has had little experience with similar problems, or the problem is sufficiently complex, then a quantitative analysis of the problem can be especially important consideration if the manager's final decision. When using the quantitative approach, an analyst will concentrate on the facts or data associated with the problem and develop mathematical expressions that describe the objective, constraints, and other relationships that exist in the problem. Then, by using one or more quantitative methods, the analyst will make a recommendation based on the quantitative aspects of the problem. Although the skills in the qualitative approach are inherent in the manager and usually increase with experience, the skills of the quantitative approach can be learned only by studying the assumptions and methods of management science. A manager can increase decision-making effectiveness by learning more about quantitative methodology and by better understanding its contribution to the decision-making process. A manager who is knowledgeable in quantitative decision-making procedures is much better positioned to compare and evaluate the quantitative and qualitative sources of recommendations and ultimately to combine the two sources in order to make the best decision. Decision modeling. Models are representations of real objects or situations. The three forms of decision models are iconic models or physical replicas, scalar representations of real objects. Analog models, physical in form but do not physically resemble the object being modeled. Mathematical models represent real-world problems through a system of mathematical formulas and expressions based on key assumptions, estimates, or statistical analysis. Generally, experimenting with models compared to experimenting with a real situation requires less time, is less expensive, involves less risk. The more closely the model represents the real situation, the more accurate the conclusions and predictions will be. Decision modeling. Some of the most basic quantitative models arising in business and economic applications are those involving the relationship between a volume variable, such as production volume or sales volume and cost, revenue and profit. Through the use of these models, a manager can determine the projected cost, revenue, and or profit associated with an established production quantity or forecasted sales volume. Financial planning, production planning, sales quotas, and other areas of decision making can benefit from such cost, revenue, and profit models. Some of the most basic quantitative models arising in business and economic applications are those involving the relationship between a volume variable, such as production volume or sales volume, and cost, revenue, and profit. Through the use of these models, a manager can determine the projected cost, revenue, and or profit associated with an established production quantity or forecasted sales volume. Financial planning, production, and sales and other areas of decision making can benefit from such profit models. Linear programming is a problem-solving approach developed for situations involving maximizing or minimizing a linear function subject to linear constraints that limit the degree which the objective can be pursued. Integer linear programming is an approach used for problems that can be set up as linear programs with the additional requirement that some or all of the decision recommendations be integer valued. Nonlinear programming is an approach used for problems that can be set up as linear programs where some of the decision constraints and recommendations are nonlinear. Project scheduling, or PERT, Program Evaluation and Review Technique, and CPM, Critical Path Method, help managers responsible for scheduling and planning to control projects that consist of numerous separate jobs or tasks performed by a variety of departments, individuals, and so forth. Inventory models are used by managers faced with dual problems of maintaining sufficient inventories to meet the demand for goods and services, at the same time incurring the lowest possible inventory and holding costs. Waiting time or queuing models help managers understand and make better decisions concerning the operation of systems involving queues or waiting lines. Simulation. Simulation is a technique used to model operation of a system. This technique employs a computer program to model the operation and perform simulation computations. Decision analysis can be used to determine optimal strategies in situations involving several decision alternatives and an uncertain pattern of future events. Goal programming is a technique for problem solving using multi-criteria decisions, usually with the framework of linear modeling. Analytic hierarchy process is a multi-criteria decision-making technique that permits the inclusion of subjective factors in arriving at a recommended decision. Forecasting models are techniques that can be used to predict the future aspects of a business operation. Markov process models are useful in studying the evolution of certain systems over repeated trials, such as describing the probability that a machine functioning in one period will function or break down in another period. Let's look at an example of decision management. Let's look at Mattel Plastics cost, revenue, profit modelings. Mattel Plastics produces a line of cell phone covers. The best-selling cover is the Panther model. It's a slim but very durable black and gray plastic cover. Several products are produced on the same manufacturing line, and the setup cost incurred each time a changeover is made for a new product is $3,000. The setup cost is a fixed cost that is incurred regardless of the number of units eventually produced. In addition, variable labor and material costs are $2 for each unit produced. The cost volume model for producing X number of units of Panther can be written as C times X equal 3,000 plus 2 times X, where X is the production volume in units and C times X is the total cost of producing the volume of units. Marginal cost analysis. Marginal cost is defined as the rate of change of the total cost with respect to the production volume. That is the cost increase associated with 1 unit increase in production volume. So we have our cost formula. C times the number of units produced equals 3,000 plus 2 times the number of units. So in the cost model equation we see above, the total cost is C times X will increase by $2 for each unit of increase in the production volume. So the marginal cost is $2. Mattel Plastics marginal revenue analysis. Suppose that each Panther cover sells for $5. The model for total revenue can be written as revenue times X equals 5X, where X is the sales volume and R times X is the total revenue association with selling X units. Marginal revenue is defined as the rate of change of the total revenue with respect to sales volume. That is, the increase in total revenue resulting from 1 unit increase in sales volume. In the model of the equation above, we see that the marginal revenue is $5. So now we can do a total profit analysis. The total profit is denoted as P times X, which is the total revenue minus the total cost. Therefore, the following model is associated with producing and selling X units. P times X equals R times X minus C times X. Using this equation, we can now determine the total profit associated with any production volume of X. So now we can do a break-even analysis. The break-even point can be found by setting the total profit expression equal to 0 in solving for the production volume. Now we can calculate the break-even point using the same cost formula. The break-even point can be found by setting the total profit expression equal to 0 and solving for the production volume. We have P times X equal negative 3,000 plus 3 times X equals 0. With this information, we know the production and sales of the product must be greater than 1,000 units before a profit can be expected. At 1,000 units, total profit is 0. The graphs of the total cost model and total revenue model and the location model for the break-even are shown in figure. In this session, we summarize the decision-making theory approach, discuss the steps of problem-solving and decision-making, described analysis and decision-making, explored decision modeling, discussed decision management science techniques, and explored an example. Thanks for watching, and I'll see you in the next video.